right, everybody, we're back. Okay, talking about pedigree charts again. We're going to do another example to help you guys understand this concept a little better, okay? So we're still going to be working with these two genes, okay? The dominant version gives you black hair. The recessive version gives you blonde hair, okay? Remember that a circle, okay, represents a female, okay, and this line here connected to a square, okay, means that the female, okay, had children with the male, okay? So squares are male, circles represent female. Okay, now, okay, when we draw this line here, that means that they had kids, and in our particular example, let's say they had 3 kids. This time, let's say they had all boys. Okay, now we have mom, dad. Okay, so let's do that. Mom, dad. Okay, mom and dad got married. Okay, got married, had kids, boy, boy, boy. Okay, so this is a son, or a boy. Okay, now let's imagine that both parents had blonde hair. Okay, so their phenotype was blonde hair for both parents. Okay, so mom had blonde hair, dad had blonde hair. What genotypes will they need to have blonde hair? Well, if you're following along, you would know that they need to be homozygous recessive. Okay, now what will the boys look like? What would be the boys' phenotype? Well, remember, okay, if dad only has recessive genes to give, right? Okay, and mom only has recessive genes that she can give, right? Because one gene comes from mom, one gene comes from the other. Then all the kids are going to have to be also homozygous recessive. If they have 100 kids, 10 kids, 5 kids, every single kid will always have blonde hair. Why? Because the parents only have recessive genes to give. Okay, now let's do one more problem. Okay, so here we go. We have mom and dad. Okay, so we got mom and we got dad. Okay, here it is. Okay, oops. So mom and dad. All right, now we're still using the same 2 genes, all right? We're using the dominant version, and we're using the recessive version, okay? But this time, okay, what we're gonna do is, okay, I want both parents, okay, to have black hair, and so we're gonna say that their genotypes are homozygous dominant for both, okay? Now, when they had kids, let's say they had 3 kids. Now, it doesn't matter if they're boy or girls, but we're going to go ahead and put 1 daughter, so this will be a girl. Okay, this one right here is going to be a son, and let's say they had another girl. Okay? Okay, now, what will be their genotypes? So what are going to be the genotypes of the kids? Well, remember, we got to look at the genes. Mom has to give a gene, dad has to give a gene. Okay, so therefore, okay, mom only has dominant genes to give. So therefore, mom would give a dominant gene, dad is going to give a dominant gene, so the girl's going to be homozygous dominant. Okay, and we go through the same process. All the kids okay, will be homozygous dominance. Okay, if they have a third kid, or a fourth kid, I'm sorry, we're going to represent that with a diamond, right? So here's my question to you. What are the chances that this kid will be blonde? Okay, now what are the chances that this kid will be blonde? And the answer to this question will be 0%. Because, remember, to be blonde, you have to get 2 recessive copies. Since mom doesn't have any little a's to give, dad doesn't have any little a's to give, then there's no way that the kids will ever have blonde hair. All right, guys, so to summarize, remember, okay, this was mom. Mom had black hair. That was her phenotype. Okay, dad had black hair. That was his phenotype. Okay, they had 3 kids. All the kids had black hair because parents only can give dominant genes. So their phenotype of all the kids is black hair, just like the parents. And then the last question I asked you was, remember, what would be the chances, okay, of the next kid having blonde hair? Well, it's going to be 0 because the parents don't have any of the recessive genes to give their kids.